Okay, let's finish up the lecture with a few practice problems. These come from practice problems 2H. And the first is regarding the center of mass. Remember that if we have a collection of particles, the physics of such a system is very complicated, but if we locate the center of mass of the system, let's say somewhere over here, then the motion of the center of mass will be just like uh, a particle placed at the center of mass point with all of the mass of the whole system. So in particular, if we have an isolated system that's not moving, then the center of mass will simply remain at the same point. And so that's what this problem is testing you on. An 80 kilogram man and a 60 kilogram woman are standing 7 meters apart on frictionless ice. They hold the ends of a rope and start pulling themselves together. At the time they meet, the woman has moved a distance of what? Okay, so let's just draw the scenario that's been explained in words. We have this 60 kilogram woman. Let's put her at the origin. Let's put the man at 7 meters on the x-axis because we're told he's 7 meters from the woman. And then we can locate where is the center of mass. Let's figure out what is the center of mass, okay? So 60 kilograms at location 0, so we do 60 times 0, plus 80 is the mass, times the location is 7, so 80 times 7, divided by the sum of the masses, 60 plus 80, and that comes out to 4 meters. All right, so now as the woman and man pull on the rope, the center of mass will remain in the same place because there's no external forces that would move the center of mass. It starts from rest, it will remain at rest. So they will keep coming closer and closer together until they meet at the center of mass point. So the woman will move from the origin to the center of mass point, which is at a distance of 4 meters. By the way, the reason why I put the woman at the origin was so that because they asked for how far the woman moves, if I just locate the center of mass, that's a very simple calculation to figure out how far she's moved. Okay, the next problem is about torque. So the length of a bicycle pedal arm is 0.15 meters. A downward force of 200 newtons is applied to the pedal by the rider's foot. When the arm makes an angle of 150 degrees with respect to the vertical, the torque that this force exerts about the pivot point is what? I actually remember this problem when it was given on the test a few years back, and the most difficult thing about this problem was actually understanding the picture. So I'll help you with that. So this is a vertical line. And we have this arm for the pedal, for the bicycle pedal, this arm here. It makes a 150 degrees angle with the vertical. And so here's the pedal. So you're going to press with your foot. You're going to press in this direction here. Okay? And we're going to press with a, so by the way, downward means vertically downwards. Press with 200 newtons. And we want to know the torque. Okay, so we have, here's the force, here is the rotation point. Okay, so this is our vector r, this is our vector the force, and we need the angle between them. This phi angle is 30 degrees. So we have r times f times the sine of phi is 0.15 is the is r is 0.15 meters, times 200 is the magnitude of the force, and the sine of 30, and so we end up with 15 Newton meters. Okay. Moving on, let's do number 14. This is about the moment of inertia. The moment of inertia of a solid sphere about its center is 2/5 mr squared, where m is its mass and r is its radius. Given this information, the moment of inertia of a solid sphere about an axis that is tangent to its surface is what? Okay, so we have a solid sphere, and we want to know the moment of inertia about this axis rather than the center of mass axis here. Okay, we want to know the moment of inertia here. All right, this is just a straightforward application of the parallel axis theorem. So the separation between the two parallel axes is the radius of the sphere, so that's r. So the moment of inertia about the new axis is the moment of inertia about about an axis going through the center of mass, plus the mass of the sphere times the separation, which is r squared. Okay, so we have the formula that this is 2/5 mr squared, and then we have mr squared. So 2/5 plus 1 is equal to 7/5 mr squared. Okay, let's go on. A flywheel is rotating at 20 radians per second when it starts to undergo a constant angular acceleration alpha. After 9 seconds of constant acceleration, it has rotated 450 radians. What is the angular acceleration? Okay, this is just straightforward uniform angular acceleration problem. We have an initial angular speed of 20 radians per second, and we are told, that the change in the angle, theta minus theta 0, is 450 radians. And we want to know the acceleration, the angular acceleration. Now we know the time, delta t. So we need a formula that involves theta minus theta 0, delta t, and we want it, and omega 0, because we know that. But we want to have an equation with alpha because that's what we want to solve for, and this fits the bill perfectly. Theta minus theta 0 is equal to 1/2 alpha to delta t squared plus omega 0 delta t. Plug in all the numbers, 450 for theta minus theta 0, delta t is 9, put that in here, and then omega 0 is 20 radians per second. And so now we get 40.5, that's 81 over 2 is 40.5 alpha, plus 9 times 20 is 180. And then we can subtract 450 minus 180, divide by 40.5, and we get 6.67 radians per second squared.